save water, how to conserve the water to agricultural practice. How the individual way we can do it, which I have discussed in last session. Now in this session I will be discussing on saving the water during agricultural practice. So mostly agricultural process use maximum amount of water, consumable water. Efficient irrigation method reduces the water dependency 30 to 70% of water, how much we consume. Last class I have discussed for 1 ton of rice, how much water is essential. Now by using this drip irrigation technology, you can understand from this image that all the water is directly supplied to the root. The water does not erode the soil, it directly goes into the plant and it is being efficiently utilized. This is called drip irrigation technique. Next is called sprinkler irrigation system. By this, hydraulic system and a rotation fixture. By this fixture, the water is being sprinkled all over the place. These are all provided where you don't have natural slope in the agricultural field. So if you want to make any slope or more groundwork has to be done, this kind of sprinkler irrigation system reduces the water need, and when the water is being sprinkled, it directly is sprinkled into the leaves, stems and roots of the plant. So it consumes that water. There will be very much less runoff of the agricultural water. 20 to 40% of water is being saved and it is being evenly distributed to all the plants. The micro irrigation is this. These are all the types of micro irrigation. One is drip irrigation and sprinkler irrigation. These are all called micro irrigation system, which improves the efficiency of the system. Now, the subsurface irrigation reduces the evaporation. Like this, you have drip irrigation below the soil. The water is supplied below the ground surface. There is no point of evaporation. Now the water is directly letted into the root, and this type of irrigation system is called subsurface irrigation system. In the places such as Rajasthan and in the cities, what happens? The water will automatically get evaporated, 30 to 40% of the water. In these places, subsurface irrigation systems like this can conserve the water. Next thing, crop selection. According to the availability of water, we don't have continuous rainfall throughout the year. Particular time period we have more rainfall and rest of the time we have less and nearly dry. According to the availability of natural resources, we have to plan the agricultural system. Whenever we have less water, we can plant the low water consuming crops like millets and pulses. Like these crops consume very less amount of water, nearly 20 to 50% of water. Then crop rotation. Throughout the year, the farmers will not practice a single crop. They will follow a crop rotation according to the nutrition which is being consumed by the plants. So plants also consume nutrients from the soil. If the first year it is being planted with legumes, the next year can be planted with broccoli and cabbage. The third year can be tomato and potatoes. The fourth year can be root crops. Like this, the soil also has sufficient amount of time in order to naturally recycle the soil state. Like this is an example of three sisters method. What do you mean by this? Planting corn, which provides the structure. Whenever you are planting any crops nearby, if you have corn, which provides the structure to the nearby crops. Example, beans, squash, etc. These provides as the structure. Next thing, beans fixes the nitrogen and squash shades the soil to prevent weeds together. Like this, three sisters methods are there. So along with the same land of agriculture, you can plant with. These are all agricultural practice and agricultural engineering which you can follow. This is a time frame. At what time period we can sow the seeds? Cotton have the best time period between July to September, and dense vegetation during the September half to November. Like this, rice planting days as well as harvested days. So you have flooded zones nearly in June. In June you have flooded time. After June, you have dense vegetation stage. These are all harvesting stage. Now, like that, you can plan according to the cropping calendar, which reduce unnecessary irrigation. Next thing, soil moisture management. Even though if we water the plants, in order to reduce the evaporation, mulching is a process is being done. Mulching is a process wherever you have the stem of the plant, at that place you have small opening. Rest of the places are covered with this kind of plastic warps. So these are all organic, and what happens, this will not allow the water to evaporate from the soil. Nearly 25% to 50% water is being saved. Organic matters increase soil water holding capacity. And whenever there is high rainfall, what happens? Naturally, whatever we fertilize it, whatever we seed it, it gets run off. So this kind of mulching prevents that, and it gives good holding capacity. Now it covers crops to reduce the moisture. Conservation of tillages. So tillages I will explain. This is called tillage. Whenever we are going to sow, wherever you have low lying area, there the seeds will be sowed in order to reduce the runoff. So this is conservation of tillage. 1 to 2 feet of holes is being done in the agricultural land. In that the seed is being sown. So this kind of technology conserves the water, reduces runoff. Proper soil structure which provides high amount of infiltration. If the top soil is being highly compacted, naturally the rainfall will not go inside, it will automatically run off to the surface layer. The penetration of water will be very less. If the water is not compacted and it is very loose, in the sense it will automatically get infiltrated and it gets into the root of the structure. So this is how we can manage in the agricultural practice. In every agricultural field or in an open land, rainwater harvesting system can be provided, not only for the houses. In this kind of agricultural land, rainwater harvesting system called farm ponds. We have land of agriculture and forest. Naturally, during a rainfall, all the water will be collected from this place. You can see here, naturally, all the water is taken here, and in this place, there is a natural embankment is being constructed. What happened? All the water is being stored here, and this can be used whenever the farmers needs water. Like this, we can provide check dams. So this is an example of check dam. Whenever there is a natural flow of water, you can provide this kind of small humps and embankments. This will reduce the runoff and increase the water storage capacity. And rainwater harvesting can store 1 to 5 million liters per year. So this natural water will get runoff. Nobody will get benefit out of it. So you have to identify the place where in the agricultural land you have the runoff, and at that place you can provide this kind of percolation pond. In aerial view you can see like this, and this infiltrates below the soil. This I have discussed in earlier sessions. Typical kind of a system is being done, capacity of 20 lakh liters, and it is being used by the 5 farmers around the places, and it is being used for 4 hectares of cultivation, around an expenditure of 1,55,000 for the construction of this. So if we spend some amount, what we can do is we can conserve the water by this rainwater harvesting system. Next thing is irrigation scheduling. When we have to schedule our irrigation is during morning or evening, because at the noon you have high amount of temperature and humidity will be there. So this increases the evaporation. Before the absorption, the evaporation happens. So proper scheduling saves 20 to 30 percentage of water. Alternative, furrow irrigation. What do you mean by furrow irrigation is, you can see here the water is being directly letted into this kind of low lying land. Naturally this water will not take away all the root and the fertilizer which lies in the top, and at the bottom all the water flows. So this is called furrow irrigation, reduces water usage. Now irrigation based on crop requirement. So this is an advanced technology whenever the water is completely dried, you have a moisture sensor. It can be installed in all the crops. So automatically the water has been pumped and delivered to the crop. So by this way you can use IoT techniques. Whenever the water has been completely dried, automatically the water will get pumped through this system. So this is called irrigation based on crop requirement, which improves the efficiency. Modern technologies, this is what I have told. IoT based system, soil moisture sensors will reduce the water usage by 20 to 40%. If the water is fully consumed by the soil, whatever water we provide for the plants, it will not get absorbed. So by this way the sensors and smart irrigation system provides water conservation. Like this, whenever we are planting the seeds, make sure that it has to be in a proper slope. If the slope is too much high, if the land is too much sloper, what happens, naturally the water takes away all the top soil, and it has to be in a particular slope, such a way that the water naturally has to go from top to the bottom. It should go slowly. So like this you can use laser, and while tractoring you can level it according to the slope, and this provides more efficiency. These are all modern technologies which can be used during agriculture. Next thing, field management practice. This is one of the technique called contour farming. This reduces the runoff. Whenever there is a high rainfall, the rain will be stored here through this embankment, and after the filling of the first layer, it goes to the second level. Like this, the contour farming reduces the runoff, and bundling helps to retain the water fields. Alternative wetting and drying saves 15 to 30 percentage of water. To wet and dry. As soon as the water is being provided to the plants, we should not again irrigate it unless if it is dried. So drying and wetting has to be taken care that you can use 15 to 30 percentage of water conservation. This is called furrow method. Last slide I have mentioned, here is also a typical example of furrow method. If you provide the water here, it automatically goes into the slope. The gravity method, you don't need any pumping system. If the water flows naturally, it get into the all the plants. Now reuse and recycling, the treated water, the domestic treated water, such as grey water, reuse reduces the water demand from the agriculture by 30 to 60 percentage. I have told that as humans we use maximum for agriculture, maximum amount of water for providing agriculture than the domestic use. So if we use the domestic wastewater for agriculture and we use the fresh water, by this way of systematic usage we can reduce 30 to 60 percentage of fresh water. Now sustainable for non-food crops, and whenever there is a rainfall, automatically during the runoff the water is being holded. All the water will be used for the plants. Next thing is groundwater conservation, preventing from over extraction, and by using only from recharge wells to improve the groundwater. Also, the farmers awareness and support policy from government we can take in order to conserve the water. Government provides subsidies whenever we use drip irrigation, sprinkler irrigation system. These are all state wise. Who can get benefited out of it? If you want to buy this drip irrigation system, the government provides 100 percentage if you buy that drip irrigation pipes and this whole system. If you use sprinkler irrigation system, 50 percentage of subsidy you can get. So state wise it is given here according to the SC ST to their financial level, they can get this kind of subsidy. And training from the government which improves the water saving methods. By these 10 ways, you can conserve the water from agricultural usage. Now let us understand how by industrial practice we can conserve the water or we can save the water. Industries consume more water than domestic, and nearly 20 percentage of global fresh water is being consumed by the industries. Now you have to understand that agriculture use 60 to 70 percentage of water. The total industrial water savings 30 to 70% is achievable. Even though we are using 20% of global water, this is achievable by the following techniques. What we are going to discuss now: 10 to 25% of energy savings can be done by using this following techniques. So this could be used according to the industry wise. In a textile industry, around 100 to 200 liters per kg of fabric we can conserve. This can reduce 60 to 80 liters. From paper industry, 250 to 300 liters per kg of manufacturing of paper, which can be saved. Steel industry is around 20 to 25 meter cube per ton of steel production, which can be conserved in power plants. 3 to 5 meter cube, around 3000 to 5000 liters of water per megawatt hour can be conserved through this following practice, which we are going to discuss now. In a textile industry, you can see here that they dye the how they dry in the sense they use the stage of wet process. What is wet process in the sense? They will use some chemicals inside the water, and a large amount of water is being used while making this process. This process is called wet process. This can be changed, and you can see that soon after they are making this kind of yellow color style, this water is being thrown out, and this water is completely a waste. This is also one of the techniques being used by textile industry. It's called process optimization. Instead of wet process, you can go for dry process. This is another technique which is being used. They will be using foam in order to color this kind of products. So from automotive or metal manufacturing industry, whenever the metals are being cut, you need lubrication. Majorly they use water as lubricants, and for coolant also they use as water. What instead they can do is they can use air sprays instead of coolants. The air sprays can be used. This reduces the water conservation in an industrial practice. These are all called process optimization. The industry can use any process according to the water availability. This can be changed. The process modification in textile or paper saves around 40 to 70 liters per unit of output. Overall, 20 to 50% can be optimized. This is called process optimization. Water auditing. Yearly, for all the industries, there will be auditing. During an audit, they will check how much natural resources an industry is consuming. What are the natural resources? How much water they consume, how much land they consume, where they throw the solid waste, how they recycle it, and how they recycle the liquid waste, solid waste, how much energy they consume. These are all called auditing. So during an audit, they will check that how much water they are consuming. For that, they need to install water meter. This ensures that how much water they consume for that industry. By monitoring that, they can split out the consumption, and where they can fine tune the conservation they can understand by their own auditing process. And installation of flow meters. This is an example of flow meter here. If leaks are being identified without flow meter, how much water is being used, we are unaware of that. If we use that water meter, we can identify which process consumes more water, and that can be optimized, can be continuously done year by year, and which reduces the water usage. Next thing is zero liquid discharge. What do you mean by ZLD? Zero liquid discharges. I have told that industries consume water. After consumption of that water, it should be treated by this kind of sewage treatment plant, and again that water has to be used. This process has to be continuously happening. there should be no water which has to be discharged in the river. So if there is any waste, it could be a solid waste, not a liquid waste. If there is any liquid which can be treated here, again they can use for industrial process. For cooling process, this kind of water can be used multiple number of times, which reduces freshwater requirement 80 to 90 percentage, and water recovery efficiency will be 90 to 95 percentage. And the sludge generation is also reduced by 30 to 40 percentage by advanced system. This is called sludge. Whenever the process is happening, the water carries some dust particles. These dust particles are being collected, and this will be called sludge. And in day to day, we will be using engine oil for our vehicle. Soon after we use for 1 or 2 years, the engine oil will get this kind of impurities. They have a process, and after purifying this process, you will again get that same engine oil, except this impurities will be taken outside. Like the way all the components can be reused, even water, whatever has been industrially used, it can be again used for the next process. It's called zero liquid discharge. And efficient equipment and technology. Industry consumes water. Now they should have this kind of equipment and technology which can reduce 60 to 70 percentage of water, and automated shut-off valves can reduce wastage by 10 to 25 percentage. So these are all water efficient machinery, cuts the water usage 20 to 40 percentage, and these are all the different sensors the industries can use for water conservation only. This is called turbidity sensor. If the water is too much dirty, it can be identified by the sensor, and immediately the water will go to the next stage of treatment process. Next thing is liquid flow meter. Soon as 1000 liter of water is required, if you set it automatically, soon after the 1000 meter is being inletted, it will stop the flow. So like this, different sensors are there. Temperature sensor, if you are doing any boiling, if it reaches 1000 degrees centigrade, the temperature sensor will identify that 1000 degree, and you need water for cooling that. So if you are supplying that water, this much of water is being sent, and after cooling, the temperature will be identified. Soon as the boiled water, it will be letted out, and next fresh water will be letted in. If these kind of sensors are used in industries, which can reduce the water usage. Cooling water management. Now, majorly the water used for cooling in atomic power stations. Cooling system are there. These are all called cooling towers. You can see this in thermal power plant, nuclear power plant, etc. Whenever the water is being supplied, the cross section of this cooling tower here, and whenever the heated water is being sent in this tower, you will be having a pipe here. Through this nozzle, the hot water will be sprayed, and you will be having a membrane. The sprayed water will be observed by this membrane, and at the bottom the cool air will be sent up. So what happens, automatically the cool air consumes all the heat and it goes out, so that you can see the vapors are here. So this heat gets exhausted here. So by this way of cooling water management, you can reuse that same water again for the next set of manufacturing. This is a rainwater harvesting system for industry. For a housing, you can conserve very less because the infrastructure is very less. For an industry, you can collect around 6 million liters per year. For an industrial roof of 10,000 meters square, you can see large number of rainwater harvesting system. By this way, you can collect and reuse that rainwater harvesting for your manufacturing process. And the last thing is waste treatment and reuse. ETP is called effluent treatment plant, and STP is sewage treatment plant. If you are treating this water after consuming from this industry, you can see the water when it is inletted. After the treatment, you can see the water here, which can be reused again, or it can be letted in for agricultural process and gets high amount of yield during the irrigation. So advanced membrane systems achieves 90 to 95 percentage of reuse. If you are using 100 liters, 95 liters of water can be reused again. Only 5 liters get waste. So this kind of system can be used nearly for 5 to 10 cycles. Before letting the water out, you can use this. By this way, you can use the agricultural water and industrial water efficiently and conserve this